Plastics recycling is failing. Globally, over 350 million metric tons of plastic are produced annually, but according to the OECD, only 14 to 18% of that is recycled. In the US, it's even bleaker. The recycling rate stands at about 8.4%, a number that has been on the decline even as the public has become more aware of the plastic waste crisis.
While we're also shocked at the amount of plastic waste we generate each day, virgin plastic production keeps increasing 4 or 5% year over year.
China used to be able to profitably recycle much of the world's plastic waste, but that came to a halt in 2018, and now we have to deal with it domestically. Problem is, most plastics just aren't recyclable, and even those that are degrade in quality each time they're remade, meaning they'll eventually end up in the landfill too.
So we can't recycle our way out of this problem.
Or can we? Mechanical recycling won't save us. That is, chopping plastic up, melting it down, and remaking it the way that we do now. Instead, the industry is betting big on something called chemical recycling, which can handle all types of plastic waste.
This new technology can take those plastics, break them down into the raw materials, and make brand new quality plastics out of them, which gives you a much bigger expansion in terms of potential end markets.
With governments around the world increasingly banning single-use plastics, industry groups like the American Chemistry Council are hoping that chemical recycling can save both the industry and the environment. Companies like Brightmark, Plastic Energy, and Agilix are now trying to turn plastic into fuel and plastic back into plastic.
We are going to have plastics in the environment for the foreseeable future, and I want to find what is the most optimal way to reduce waste and increase the environmental sustainability aspect of those products that we use.
But skepticism abounds. After all, plastic made from scratch is actually cheaper than recycled plastic, so how will the economics even work out? And can turning plastic into fossil fuels really be considered recycling? Shouldn't we just focus on producing less in the first place? It's up for debate. There are thousands of varieties of plastics, but 7 main categories, of which only 2 can be recycled by traditional means: PET, which water bottles are made of, and HDPE, used in things like milk jugs and shampoo containers. Sorting plastics and removing contamination is labor-intensive work. And so, since the 1980s, the United States, alongside other nations like the UK and Australia, sent much of its plastic waste to China, where cheap labor allowed Chinese producers to profitably recycle it. But as single-stream recycling became the norm, and plastic was thrown in the same bin as glass, cardboard, and other materials, China noticed increasingly high contamination levels. After years of warning, the country set strict new contamination limits on imports that were nearly impossible to meet, leaving wealthy nations scrambling to find new overseas markets.
What we have done over the last few years is to export to countries that they had less infrastructure of what we have, and then creating a much bigger problem.
So why not just develop the infrastructure to deal with it locally? Basically, mechanical recycling in the US just isn't profitable without incentives or subsidies.
Virgin plastic is incredibly cheap, and we are seeing traditional mechanical recycling operations shutting down because it simply does not pay. They cannot sell their recycled plastic at a rate that would justify paying people to collect it.
But even as states like California try to prop up their curbside recycling programs and centers with subsidies, there's still just so much that can go wrong. While number 1 and number 2 plastics are recyclable, about 70% end up in a landfill or incinerator anyway.
It's too contaminated or it's too difficult to separate, and then the recycled polymer is sort of low grade. And then on top of that, it's typically too expensive.
Absent strong regulation, public pressure, or true altruism, there's just no reason why a corporation would pay more for lower quality recycled plastic.
So we need to find something else. And then, of course, something else would be switch materials or source reduction, use less. But obviously, that would be bad news for the plastic industry. So I think they see the only way forward is chemical recycling.
Enter chemical recycling, a process that can break down any plastic, type 1 through 7, into its molecular building blocks, and then theoretically convert it into virgin quality plastic, chemicals, or diesel and petrol fuels.
There's been a huge investment in these chemical recycling technologies in recent years. They've been very hyped by industry. They're saying that these technologies are going to allow them to capture a much broader stream of plastics and turn them back into plastics like new, so we could get more of a circular economy with that.
The most common technology used in this process, pyrolysis, is not new. It involves heating up a material like waste plastic in an oxygen-starved environment, which causes it to break down into a mix of simpler compounds, which are then used as building blocks for new products. But critiques abound. Tongri's organization, the Global Alliance for Incinerator Alternatives, or GAIA, recently released a report which concluded that no chemical recycling facility in the U.S. is turning plastic back into plastic at a commercial scale yet, though there's been many attempts. Of the 37 chemical recycling facilities proposed in the U.S. since 2000, GAIA reports that only 3 are operational, and they're mostly turning plastic into fuel, which the organization calls the opposite of an eco-friendly solution. The companies themselves, though, beg to differ. Brightmark, founded in 2016, is building a commercial-scale plastics-to-fuel plant in Ashley, Indiana, and aims to process 100,000 tons of plastic by 2021. It will sell fuel from this plant to BP.
So ultimately, our goal is to produce less combustible fuels. There are at least 14% less greenhouse gas emissions associated with the fuels that we produce versus pulling crude oil or natural gas out of the ground.
In addition to fuels, Brightmark's process also produces paraffin waxes, and Powell says the tech is ready to convert plastic back into plastic. They just need customers.
I think the market is there, and I think what you would see from us in the future is relationships with folks that achieve our goals around circularity and their goals around circularity, because we can do it now.
But in the meantime, Tongri questions whether turning plastic into fossil fuel is really a solution worth supporting.
Is plastic to fuel better than, say, syngas derived from coal? Yeah, probably, but who uses that? It's on its way out. These are not clean fuels. Whether they are absolutely the dirtiest, or they're the second dirtiest, or they're the third dirtiest, they're clearly fossil fuels, and they are highly contaminated fossil fuels.
Then there's UK-based Plastic Energy, which is turning plastic back into plastic on a commercial scale at 2 facilities in Spain.
We targeted to have a processing capacity sometime by 2023 of about 300,000 tons of end-of-life plastics per year.
Much like Brightmark, the company started off producing fuels, also through a pyrolysis-based process that converted plastic waste into naphtha and diesel. But now, Montreal says they're totally focused on plastic-to-plastic recycling.
Since April this year, 100% of our tech oil is used to create new plastics. We are committed to the creation of a circular economy for plastics going forward.
Montreal says that Europe's ambitious environmental goals provide unique incentives for this type of technology to flourish.
We have commitments to double the recycling quotas in Europe from about 5 million today per year to 10 million tons per year by 2025.
He also cites Europe's high landfilling fees and multi-stream recycling infrastructure as advantageous. With plastic, glass, and cardboard already separated at the source, Plastic Energy can acquire difficult-to-recycle plastics more easily and economically than in the U.S. As the company tries to increase its processing capacity by over 2,000% in the next 3 years, it may face competition from Oregon-based Agilix, which is also trying to turn plastics back into plastics and is looking to expand internationally.
We have a pathway and a roadmap to take plastic recycling from the current 10% to upwards of 90%.
Agilix was one of the earliest companies in this space. Founded in 2004, it ran a plastics-to-fuel operation until 2015, providing jet fuel to the Department of Defense. Low oil prices forced the company to pivot, and now Agilix specializes in converting polystyrene back into styrene, which is used to make disposable cups, takeout containers, and packing foam. Agilix is often hailed as a leader in the space, but Gaia has called its efficiency into question, reporting that only 1/10 of the waste that Agilix processed in 2018 was actually turned into styrene, a figure that the company disputes.
So yes, they were significantly off on the yield numbers. And if our yields were in a 10 to 20% range, we would not have an economic plastic recycling pathway that the top companies in polystyrene have embraced.
While Gaia says the company has not proven that it's capable of recycling plastic on a commercial scale, Agilix is planning to expand its capacity across the US, Europe, and Asia, in conjunction with a number of petrochemical partners such as America's Styrenics and Ineos.
The facility in Chicago that we're developing with Ineos Styrolution will be 100 tons per day, 10 times the size of our Tigard, Oregon facility. And as we replicate those, the scale of our recycled styrene will begin to have a significant impact on the market.
Cooper says the company hasn't run a life cycle analysis to see how its recycled polystyrene compares to virgin polystyrene, but estimates the process to be between 40 to 70% cleaner. This number, too, is up for debate. But it's more than just a disagreement over statistics. Fundamentally, it's a disagreement over priorities. Basically, there's not a consensus on whether chemical recycling will represent an important part of the plastic waste solution or an expensive distraction from what many believe ought to be the real priority, making less plastic.
There are people who embrace chemical recycling as an emerging technology with an evolution path. There are others more focused on reducing the amount of plastics that we use as a country and as a world.
Not surprisingly, there's big policy disagreements as well. For example, the fact that plastic industry groups enthusiastically support chemical recycling while opposing policies like single-use plastic bans or plastic taxes leaves many skeptical that the industry would ever pursue eco-friendliness over profits.
The industry is investing so much money in chemical recycling because they really want to convince us that they can continue to churn out ever large quantities of plastic and solve the problem downstream.
Tongri and many other environmentalists believe that instead of pursuing chemical recycling, the plastic waste problem is best addressed through legislation, in particular, extended producer responsibility laws that force plastic producers to bear the cost for the environmental impacts of their products.
There are proposals that would impose a tax on plastic producers proportional to the environmental and health harm that they cause.
The idea is that this would lead to less plastics production overall, drive growth in the market for plastic alternatives, and incentivize consumers to turn to reusable materials instead. But many champions of chemical recycling support a more free market approach.
If virgin plastics cost more because there's a tax on them, that helps us out. But I think that open market competition is really the true way in the long run to foster the innovation and the efficiency to drive higher recycling rates across all plastic types.
Cooper's position is shared by industry groups like the American Chemistry Council and the Plastics Industry Association, who say that consumer demand and corporate pledges will make recycled plastic an attractive option, even if virgin plastic remains cheaper. Others, though, say legislation and chemical recycling both have a role to play.
Regulatory and governmental frameworks have really driven us to where we're at the point now where there is an absolute demand to deal with the issues of post-use plastics. In the future, maybe there won't be a need for plastics and we find a better way of doing things. But for the foreseeable, we are going to have plastics in the environment. And so what we do is already environmentally better. It will ultimately get even better as time goes on.
But for now, serious doubts about chemical recycling's efficacy, environmental footprint, and scalability remain, leading many to withhold support in favor of starting with simpler solutions.
Overall, I always like to start with the easiest, most obvious solutions. And I think there are many, many places where we could just use less plastic without compromising our quality of life. But I think it'll take a lot more than just coming up with a handful of amazing technologies to fix this.